Hello student, I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss a structure of water. Last class I have discussed physical properties of water. Now I am going to discuss a structure of water. In the gas phase, water is a bent molecule with a bond angle of 104.5 degree and OH bond length of 95.7 picometer. It's a diagram I will send. Okay, it is a highly polar molecules. Highly polar molecules means it have charge. Its orbital overlap, that is a picture. In picture you will see orbital overlap picture that you will see in the diagram. Okay. In the liquid phase, water molecules are associated together by hydrogen bonds. The crystalline form of water is ice. Here is important. The crystalline form of water is ice. At atmospheric pressure, ice crystallizes in the hexagonal form. This question is asked. At atmospheric pressure, ice crystallizes in the hexagonal form. It means ice has hexagonal structure. But at very low temperature, it condenses to cubic form. Two structure there means at atmospheric pressure, ice crystallizes in the hexagonal form at 1 atmospheric pressure. But at very low temperature, it condenses to cubic form. Density of ice is less than that of water. Therefore, an ice cube floats on water. In winter season, ice formed on the surface of a lake provides thermal insulation, which ensures the survival of the aquatic life. This fact is of the great ecological significance. Actually, ice is a function as a insulator. It will not allow heat to go inside. Hence, inside water will be warm. Water will be warm, and this is a very important for ecological significance, because many aquatic life will remain inside. If ice would have not you can say insulating material, ice would have not insulated, then all water either it would have been become warm in summer, or in cold it would become very cold. Hence, this is a very can say important role of ice. Its insulation property is very important. It does not allow, you can say, all water to become cold or warm. Okay, it is insulating. Okay, it provides thermal insulation, which ensures the survival of the aquatic life. This fact is of great ecological significance. Now I am going to discuss now a structure of ice. A structure of ice, already told you that it is a hexagonal at 1 atmospheric pressures, and at low temperature it is a cubic structure. Now more you know, ice has a highly ordered 3-dimensional hydrogen bonded structure. Okay, this you understand, this is the ordered highly ordered three-dimensional hydrogen bonded structure. It means it has length, breadth, height. Already you have seen the ice. Examination of ice crystals means if you will see the ice crystal with X-rays shows that each oxygen atom is surrounded tetrahedrally by 4 other oxygen atoms at a distance of 276 picometer. Each oxygen atom is surrounded tetrahedrally by 4 other oxygen atoms at a distance of 276 picometer. Hydrogen bonding gives ice a rather open type structure with wide hole. These holes inside the ice structure, some hole will be there. Hydrogen bonding gives ice a rather open type structure with wide holes. These holes can hold some other molecules of appropriate size. Interstitially you can tell. Interstitially means inside, and you can tell ice has a cage type of structure. CAGE, cage. Ice has a cage type of structure. Okay, this question may be asked. Chemical properties of water. Now I am going to discuss chemical properties of water. Water reacts with a large number of substances. You know, water is very, very important. It can react almost all things. So many things dissolve in that. And water also reacts with, you can say, a large number of substances. Okay, then few examples I will tell you. Okay, first, it has amphoteric nature. Water has a amphoteric nature, means it can function as acid as well as base. Question is asked, what is the meaning of amphoteric nature? Amphoteric means it can behave as acid as well as base. It has the ability to act as an acid as well as a base. That is, it behaves as an amphoteric substance. In the Bronsted sense, it acts as an acid with NH3. It acts as an acid with NH3 and a base with H2S. Okay. Reaction I am telling you, H2O means liquid. You know, H2O is liquid. H2O plus NH3. Now NH3 will be H2O. Now it function as a acid. NH3 function as a base, acid base reaction. Then it forms a OH minus, hydroxyl ion plus ammonium ion. When water will function as acid and NH3 function as a base, you know, then after the reaction it will give product hydroxyl ion OH minus plus ammonium ion. And now H2S this now H2S will behave as a base. Now H2S behave as a base with, you know, H2O behaves as a base with H2S. H2S is as acid. Hydrogen sulfide, it function as a acid. Then now here H2O function as a base. Base plus acid, again it will give salt, means ionic compound. And here you can say H2O plus H2S, hydrogen sulfide, it gives a hydronium ion, H3O plus, because now H2O will take one hydrogen and it will turn to H3O plus hydronium ion, and what will remain? That is the HS minus hydrogen sulfide anion. Okay, the autoprotolysis itself ionizes. Autoprotolysis means self-ionization. Autoprotolysis means self-ionization. The autoprotolysis of water takes place, that I am telling you that autoprotolysis of water takes place as H2O plus H2O, means both will react. H2O plus H2O, both will react and it will form now one molecule of H2O. It will function as an acid, and other molecules of H2O will function as a base. Then now H2O you can consider as a acid 1 because it will give a conjugate acid. Okay, conjugate acid, conjugate base, here it will give like this only. Then H2O consider as it is functioning as a acid, then you consider as a acid 1, and after reaction it will take one electron, it will give H3O plus, that is the conjugate acid 2. Conjugate acid 2 means acid 1 given acid 2 after taking hydrogen ion. Already I have discussed these things, conjugated acid, conjugated base. Now base, what about the base? Then H2O has H2O, another H2O considered as a base 2. Then now it has given one H. Then after giving, what will remain? OH minus will remain. OH minus. Then base 2. Base 2, that became base 1. H2O after relieving one hydrogen, it converted to OH minus. OH minus is a strong base. Then base, weak base gives a strong actually base 2, that gives base 1, that is called conjugate base. Then this is called autoprotolysis, means water itself will react. One molecule will function as a acid, other will function as a base, and it will give product H3O plus, and other product will be OH minus. Okay. Now another reaction I am telling you, that is the redox reactions involving water. Water can be easily reduced. Water can be easily reduced, means it will give the electron. Okay, water can be easily reduced to dihydrogen by highly electropositive metals. Highly electropositive metals, as for example sodium. Then 2H2O plus sodium. Then this 2H2O, that it will lose electron actually, and it will form 2NaOH, sodium hydroxide, and it will release hydrogen. Okay, water can be easily reduced to dihydrogen, means hydrogen gas. Okay, example 2H2O plus 2Na, it gives 2NaOH plus H2. H2 is released. Okay. Now I have seen that it is a great source of dihydrogen, means hydrogen gas. That means water is a great source of hydrogen. It can give hydrogen. Okay, water is oxidized also. Now you have seen water can be easily reduced. Now you have seen reduced to dihydrogen. Now water is oxidized to O2. After reducing, it is giving H2. Okay, it is reduced to H2 because in water H2 is there. Then there they had H2O. H2O means H plus OH minus, or you can tell 2H plus O2 minus. O2 minus. Then now this H, this 2H plus, what will happen? That now this 2H plus will convert to H2. H2. Okay? And this sodium will become NOH. Sodium will become NOH. Meaning of oxidized and reduced, you know. After losing electron, it is called oxidized. After gaining electron, it is called reduced. After losing electron, it is called oxidized. After gaining electron, it is called reduced. Okay, then here H plus was there. H plus. Now, after taking electron, okay, it converted to H2. Now, here you can see other example, that is the water is oxidized to O2 during photosynthesis. This is a very, very important reaction I am telling you. For the photosynthesis, what do you require? You require carbon dioxide. You require water vapor or moisture. And third important things, you require light, sunlight. Without sunlight, there will be no photosynthesis. Photo means light. Okay. Then now carbon dioxide, 6 CO2 plus 12 H2O, more water, and it is forming a very, very important product. Our source of food, that is a carbohydrate. Carbohydrate that plants and tree it forms. That carbon dioxide plus H2O means balanced equation, you can write 6 CO2 plus 12 H2O means moisture. It will form C6H12O6. This is the carbohydrate and molecule name is glucose, and it forms 6H2O water also plus carbon plus oxygen. See how useful this reaction is there. Carbon dioxide plus water vapor, moisture, it forms glucose, and because you have taken excess water 12 H2O, then during this reaction also water is formed 6 H2O plus 6 O2, oxygen also. Means during the photosynthesis you are getting two very, very meaningful things, important things. First glucose and second oxygen gas. It happens in daytime. That's why in daytime you can say under the tree if you will sleep, it is good because it is releasing oxygen. That's why this tree is required because tree gives oxygen gas, and also plant will get its food, that is the glucose, and that glucose actually it will be present in leaves and in trees, plants, and animals will eat. Not only that leaves sometimes it is useful for us also. It is useful for us also. Okay, and tree and plant gives the fruits. In that also glucose and fructose will be there. Means carbohydrate will be there. That we are eating. Means our source of food, you can tell. This important is very, very important. Okay, then balance equation I am telling you, 6 CO2 that is the gaseous form. And another important thing that it is absorbing carbon dioxide. If in environment carbon dioxide will be more, then plant will absorb and it will convert to glucose. And again it is useful. Plant is very, very useful. Then carbon dioxide 6CO2 plus 12H2O, it gives C6H12O6 plus 6H2O plus 6O2. And it reacts with fluorine also. Water also reacts with fluorine. With fluorine also it is oxidized to O2. It is oxidized to O2. Oxidized means what? It will lose the electron. Oxidized, after losing the electron, it is called, substance is called oxidized. Then here with fluorine is electronegative, obviously it will take the electron. Then 2F2 means fluorine gas plus water 2H2O liquid, it forms 4H plus hydrogen ion plus 4 fluoride ion, means HF you can tell, hydrogen fluoride plus oxygen. Plus oxygen means during when it will oxidized, water will be oxidized, then it will form oxygen. Okay, you have seen in both cases. That is a 6CO2 plus 12H2O. It has given C6H12O6 plus water plus oxygen. Okay, during photosynthesis. And here also 2F2 plus 2H2O, then this 2H2O is giving oxygen. Okay, oxygen means balanced equation is there. 2F2 plus 2H2O, it gives 4HF. 4HF means 4 hydrogen ion plus 4 fluoride ion plus oxygen. Then you have seen water gives hydrogen gas also and oxygen gas also. Okay, now next example I am telling you, that is the hydrolysis reaction. Hydrolysis reaction, due to high dielectric constant, it has a very strong hydrating tendency, means it will absorb water. Due to high dielectric constant, it has a very strong hydrating tendency. It dissolves many ionic compounds. However, certain covalent and some ionic compounds are hydrolyzed in water. Some many things it will dissolve, but some you can say some certain covalent and some ionic compounds are hydrolyzed in water, means H2O will break in the form of H ion and H plus OH minus. That is called hydrolysis. H2O will break into H plus and OH minus. Here you can see in the example P4O10, P2O5 phosphorus pentoxide, you might be knowing P2O5 phosphorus pentoxide. It is a dimer of P2O5, it became double, just a dimer. Then P4O10, then P4O10, it reacts with water, H2O liquid, and it gives phosphoric acid, H3PO4. It is giving acid, H3PO4. Then here P4O10 plus 6H2O. Here it is actually absorbing. It is absorbing and it is converting to 4H3PO4, means acid. It is forming acid, phosphoric acid. It is called phosphoric acid. P4O10 plus 6H2O, it converted to 4H3PO4. This is a balanced equation. P4O10 plus 6H2O, it gives 4H3PO4. Now again you can see SiCl4, silicon tetrachloride, it reacts with water and it gives SiO2, silicon oxide plus HCl, HCl. Okay, silicon oxide is a basic nature. Then SiCl4 plus twice H2O, it gives SiO2 solid plus 4HCl, hydrogen chloride. Okay, that is the acid aqueous solution. Now next reaction you can see N3 minus means NS, here N3 minus is there. Okay, nitride ion, N3 minus plus 3H2O. Okay, then it will react with water, means N3 minus plus 3H2O, it gives ammonia gas plus 3OH minus. Then now N minus 3 was there and here plus 3H2O, means 6 hydrogen was there and 3 oxygen was there. Then 3 oxygen, this N3 minus has taken, 3 electron was with it. Then this electron is given to 3H plus, H plus, and it formed NH3. And what is remaining? Only 3OH minus, OH minus is remaining, 3OH minus, that is the hydroxyl ion. Now next reaction you can see, that is the hydrates formation. It forms a hydrate. Okay, hydrate. This is also important reaction. Hydrates formation. From aqueous solution, many salts can be crystallized as hydrated salt, such as association of water is of different types. Here understand that from aqueous solution many salts can be crystallized as hydrated salts, means it will associate with water molecules. Such an association of water is of different types. 3 types are there. This association of water, hydration of hydrates I am talking about, it is of 3 types. Also you can tell association of water is of different types. Then first type I am telling you, coordinated water. Means with metal in coordination compound. Actually you know that central metal ion, they will have a vacant d orbital. Then this H2O will go to the vacant d orbital. As for example, chromium H2O whole 6. Actually chromium has 3 plus primary valency. Chromium has 3 plus, that is primary valency, but it has also vacant d orbitals. Then H2O will go to the vacant orbitals. Here 6 H2O went, joined as a ligand with chromium in d orbitals, and primary valency 3 plus was there. With that 3 plus, 3 chloride ion will come, Cl minus, and it will form Cr2 H2O whole 6, and in bracket coordination, this is the coordination compound. Then this complex ion CrH2 whole 6, you can write in bracket, and outside up you write 3 plus, and if 3 minus will come in the form of 3Cl, then it will join, and it will appear as a ion, because positive and negative are there. This will be called cation. This complex ion, that is called cation, because positive charge is there and negative charge is 3Cl minus, that is already an ion. This is the one type of, you can say, this association. Now second type you can see. Second type, that is the interstitial water. Interstitial water means here simply water will be absorbed. Example, BaCl2 twice H2O. Hydrated molecule, copper sulfate 5H2O, barium chloride twice H2O. Like that way, oxalic acid also twice H2O. Then that is actually example of interstitial water. Interstitial water means as water molecules per molecules. Here in barium chloride 2H2O water is absorbed. Now third type, that is the hydrogen bonded water. Hydrogen bonded water. I told you that copper sulfate 5H2O, its color is blue. Its color is blue. If you dissolve in water, solid copper sulfate is solid. If you dissolve in water, it will give blue color solution. Now is this CuSO4 5H2O. Here what you will think, that two types of bonds are there. Hydrogen bonded water means first it will give 4H2O. 4H2O, it will go to the this d orbital. Cu, you can write Cu can H2O whole 4. Cu H2O whole 4. It is a complex ion and outside 2 plus, because primary valence is 2 plus. Okay. Then Cu H2O whole 4, and in bracket you can write outside 2 plus, that is a cupric ion, cation. Now sulfate ion will come with 2 negative, then it will form neutral, because plus 2 SO4 has minus 2, SO4 2 minus 2. But what about the 1 H2O? 5 H2O was there, 4 okay, they made coordinated bond. Then what about one more H2O? Then it will be absorbed. Then total 5. Then it will form Cu H2O whole 4. Whole 4 outside 2 plus, that is a complex ion, cupric complex ion. SO4 will be there, but after that one H2O molecule will be absorbed. Okay. Then this I have told you about 3 type of hydrates formation. One problem is there, that question is asked. Okay. How many hydrogen bonded water molecules are associated in copper sulfate 5H2O? Very good question. How many hydrogen bonded water molecules are associated in copper sulfate 5H2O? Its answer I am telling you, only one water molecule. Only one water molecule, which is joined, just like what I told, absorbed, CuSO4 and one H2O. Then 2 type of this is there. Hydration. One is bonded with d orbitals, went to the d orbitals. Other, they are, you can say, hydrogen bonded water. Okay. Then only one H2O. Only one water molecules which is outside the brackets. Coordination means outside the bracket is called coordination sphere. Inside whatever is there, complex ion, that is called coordination sphere. Okay, then only one water molecules which is outside the bracket is hydrogen bonded. Means weak bond actually होती है. Hydrogen bond always will be weak bond. The other 4 molecules of waters are coordinated. Then this I have told you about chemical reaction of water. Now other things you understand. Hard and soft water. Hard and soft water. Okay, you might have heard these terms, hard, soft water, hard water. Now, what is responsible for hard water and soft water? And how can you tell simply in an easy way that water is hard or soft? Then hard and soft water, I am telling you, how can you tell that water is hard or soft? Rainwater is almost pure. Rainwater is almost pure. Okay, may contain some dissolved gases from the atmosphere, but it is almost pure. While coming on the earth, it may have some gases may be present in the atmosphere, may be absorbed, but that is negligible. It is a pure water only. Being a good solvent, when it flows on the surface of the earth, it dissolves many salts. Presence of calcium and magnesium salts in the form of hydrogen carbonate, chloride and sulfate in water makes water hard. See, now I told you that 3 things I have told you. First 2 things you have understood, calcium and magnesium, Ca++, Mg++. Then 3 things I told you. First chloride, second fluoride, and third hydrogen carbonate, that is the bicarbonate. Hydrogen carbonate is called bicarbonate. HCO3 1 minus. HCO3 1 minus. That is called bicarbonate or hydrogen carbonate. Then hydrogen carbonate of calcium and magnesium. Chloride of calcium and magnesium. Sulfate of calcium and magnesium. If it is present in water, then water is called hard water. Again I am telling you, bicarbonate of calcium and magnesium means bicarbonate, calcium bicarbonate, magnesium bicarbonate. If it is present in water, you can tell water is hard. If calcium chloride is present in water, you can tell water is hard. If magnesium chloride is present, you can tell water is hard. If sulfate is present, calcium sulfate is present, magnesium sulfate is present, then you can tell water is hard. Then in shortcut, you can say chloride of calcium and magnesium, sulfate of calcium and magnesium, and bicarbonate of calcium and magnesium. These 3, if it is present in water, then you can tell that water is hard. Okay. Hard water does not give lather with soap. If you go to clean your cloth with soap, if water is hard, what you are using to clean your cloth, then if water is hard, then hard water does not give lather with soap. Water free from soluble salts of calcium and magnesium is called soft water. Soft water, now I am telling you, water free from soluble salts of calcium and magnesium means calcium chloride, magnesium chloride, calcium sulfate, magnesium sulfates are not present because in water it is soluble. That's what is called soluble salts of calcium and magnesium. Then if in water, or you can tell water is free from calcium chloride, magnesium chloride, calcium sulfate, magnesium sulfate, then that water is called soft water. Soft water, there is a two type of hardness, temporary hardness and permanent hardness. But soft water, hard water and soft water, then soft water will not contain calcium chloride, magnesium chloride, calcium sulfate, magnesium sulfate. This question is very, very important and always it is asked. Then you can tell water free from soluble salts of calcium and magnesium is called soft water. It gives leather with soap easily. Soft water will give leather. So soft water gives leather with soap easily. Okay. Hard water forms scum, SCUM, scum. Okay, or precipitate, you can tell, with soap. Soap contains, what is the soap actually? That question is also asked. Soap, there are two type of soap. Washing soap means for cleaning purpose, and another soap is bathing soap for taking bath. Okay. Then this cleaning to clean the cloth, soap, what is soap is used, that is, you can tell, sodium, hard, it will be hard, sodium will be present there. And for bathing, potassium will be there. This is the different. Okay. In NaOH, soda, what you are telling, then that will be present. Then here, what is actually soap? Then soap containing sodium stearate, fatty acid actually, fatty acid of sodium. Here stearate is there, then C17H35. That is a double plus 1. C17, then H35. 17 into 2, 34 plus 1. This is the alkane actually. Then this type of actually formula will be there. Then I am talking about here sodium stearate. Sodium stearate, its formula is C17H35 COONA. If in the place of NaH will be there, then it will be acid. C17H35 COOH is a carboxylic acid. But in the place of H is a plus, H plus. In the place of H plus, substitution takes place. Na plus came. Na plus. Then it became the salt. And this salt of fatty acid, actually acetic acid, that is the acid. Okay. Then that acid converts to the salt with reaction with base NaOH, stearic acid plus base, it will form sodium stearate, and this is called soap. Then this sodium stearate reacts with hard water. Now this soap, sodium stearate, reacts with hard water to precipitate out as, suppose calcium magnesium is present in water, then it will react with calcium or magnesium, and it will give, you can say, this calcium magnesium you can consider as a metal 2 plus in general. Then this sodium ion will go in water as a Na plus. Then two ions means C17H35COO, or we can tell 2C17H35COO Na is there. Two ions are there. Then this 2 sodium ion it will go. And what is the remaining stearate ion? 2 stearate ion. that will react with calcium or that will react with magnesium. Then two bonds will be formed because calcium can make two bonds. Then two you can say anion will come, stearate ion, two anion will be there and both will attach to the calcium. In general, you can tell if capital M2 plus is metal ion, then it will react with metal ion, means calcium and magnesium, and it will form C17H35 COO whole 2 into M, or M only you can write C17H35 COO whole 2 M, capital M, and it is a heavy, it is insoluble and it will settle down, means it will come as a precipitate, it will come out as a precipitate, that is called as scum, and this two ion it will go to the solution. Here capital M is calcium or magnesium. It is therefore unsuitable. It is therefore, water I am talking about, it is therefore unsuitable for laundry. Okay, hard water is not suitable for washing the cloth. It is harmful for boiler also because of deposition of salts in the form of scale. It will in boiler, where in industry big boiler will be there, water will boil, then it will come out as a salt in a large quantity. It will settle down, that is also called a scale, and it will stick to the walls of the boiler, walls of the boiler it will stick. This reduces the efficiency of boiler. Then what is negative point of this? That this you can say salts which is a stick to the walls of the boiler, they will decrease the efficiency of boiler. The hardness of water is of two types. First, temporary hardness, and second, permanent hardness. Now I will give idea about what is the temporary hardness and what is the permanent hardness. Temporary hardness, first I will tell you. Temporary hardness is due to the presence of magnesium and calcium hydrogen carbonate, means bicarbonate. Due to bicarbonate, temporary hardness happens. Temporary hardness is due to the bicarbonate of calcium and magnesium. Calcium and magnesium is common for both, for temporary hardness also and for permanent hardness also. For both calcium magnesium, ion is responsible. But if it is a bicarbonate, then temporary hardness. If chloride and sulfate, then permanent hardness. Correct? If bicarbonate is there with calcium and magnesium, calcium bicarbonate or magnesium bicarbonate, then it is a temporary hardness which can remove it easily. And when you can say sulfate and chloride is there, means calcium sulfate, magnesium sulfate, calcium chloride, magnesium chloride, then it is called permanent hardness. Easily you can't remove. Then here I am telling about the, you can say, how will you remove this temporary hardness. Then it is very easy method to remove the temporary hardness simply by boiling. During boiling, water you take and boil it. During boiling, the soluble magnesium bicarbonate, means MgCO3H whole 2 or MgHCO3 whole 2 is converted into insoluble magnesium hydroxide. In water, suppose magnesium bicarbonate is present, then after heating it will convert to insoluble magnesium hydroxide, And if calcium bicarbonate is present, then it is also converted into the calcium carbonate. Calcium bicarbonate means CaHCO3 whole 2, it will change to insoluble calcium carbonate, calcium to calcium carbonate, but magnesium will convert to magnesium hydroxide, and because both are insoluble, it will settle down. It is because of high solubility product of magnesium hydroxide as compared to the magnesium carbonate. It is not converting into the magnesium carbonate, it is converting into magnesium hydroxide. Why? It is because of high solubility product of magnesium hydroxide. Okay, that's why it is converting into magnesium hydroxide. Then now both will settle down. Then now you can filter it. Then water will become soft. Okay, then both will be precipitated of magnesium hydroxide and calcium carbonate, both. These precipitates can be removed by filtration. Okay, and what is left out, that is called filtrate. You have removed the solid magnesium hydroxide or calcium carbonate, that solid which was in the form of precipitate, you have removed. Then what is left out, that is called filtrate, and this is the good water. Filtrate thus obtained will be soft water. And reaction is very easy. Magnesium MgHCO3 whole 2, if you will boil it, then or you will heat it, then it will convert it to magnesium hydroxide plus 2CO2. Then carbon dioxide will go into the atmosphere, and only magnesium hydroxide will settle down, that will filter. And calcium bicarbonate on heating, it will convert to CaCO3 plus H2O plus CO2. Then here again carbon dioxide will go to the atmosphere and calcium carbonate will settle down, that you will remove by filtration. Then after removing this, you will get soft water. Then reaction also I told you, magnesium bicarbonate means MgHCO3 whole 2, it gives MgOH whole 2 plus 2CO2. Okay, this here sign I am talking about, for the precipitate one arrow sign is there, but in an inverted way, down means settling down. Arrow sign down, towards down, it means it is telling about it is settling down. And gas, if it is going out, then vertical arrow means gas is going outside. Then here I have told you about the boiling method. One more method is there, that also you should know, that is the Clark method, CLARKS, Clark's method. In this method, calculated amount of lime means calcium hydroxide, CaOH whole 2. Lime is added to hard water. It precipitates out. Here in this method, calculated amount of lime is added to hard water. It precipitates out calcium carbonate. After, if you add lime, then lime means calcium hydroxide, then calcium carbonate will settle down, and magnesium hydroxide, which can be filtered off. Okay, if magnesium is present, then that also it will filtered out. Then this way also you can remove calcium and magnesium. Then calcium bicarbonate plus calcium hydroxide, it reacts and it gives 2CaCO3 plus 2H2O. This is the balanced equation. CaHCO3 whole 2 plus COH whole 2, it gives a 2CaCO3 plus twice H2O. And magnesium bicarbonate, it is there, then MgHCO3 whole 2 plus 2COH whole 2, it will give CaCO3, 2CaCO3 means calcium carbonate plus MgOH whole 2 magnesium hydroxide plus twice H2O. Here you can see importance of Clark's method, that here temporary and permanent hardness both will go. Because see, magnesium bicarbonate is also converting into magnesium hydroxide. HCO3 means HCO3 means here is actually temporary hardness only you are removing. Then calcium bicarbonate, magnesium bicarbonate, that also can be removed as calcium carbonate and magnesium hydroxide. Okay, both will form, and you can filter it, it will go. Here you have to add lime. Lime means calcium hydroxide. Okay, then today I am stopping only here. Next class I will discuss permanent hardness. Thank you.